Hi there, this is Miss Page. This is lesson 5 in unit 6, so we'll call it 6.5. And it is on finding the zeros of a quadratic function that is in vertex form. And so we'll be using our algebra here, and our algebra will involve our square root property, which we learned in the previous lesson. So one of the things, of course, that it is important to understand why our math is going to be what it is in these problems is, since we're finding the zeros, what the zeros are, what they represent for the function or the graph. And so here we would say that the zeros are -4 and 1, but we should also understand that those are points on the x-axis. And so they do have ordered pairs that have a y value of 0. So we don't write them this way because the x value is by definition what we call the zero of the function. They create or produce an output of 0 for the y value. So that's important because that's going to give us how we begin our problem, is using that concept. So again, the other thing that we're going to need is the skills that we have been developing in the previous lesson on solving quadratic equations using the square root property. And so our goal with our undoing algebra first is to get x squared by itself. And so remember that we have a reverse order of operations for undoing algebra. So you undo addition or subtraction outside parentheses first. So we would add the 16 to both sides first. Then you undo multiplication or division outside parentheses. And so here we would divide both sides by 2. And now once we have our x squared equals a number structure, that is when we use our square root property. And our square root property says we can take the square root of both sides, but it also teaches us that because x is being squared, x could be positive or x could be negative. And that creates that plus minus symbol that we must put in front of the square root of the number. And then we have to simplify. And so our square root of 8, 8's not a perfect square, but we have to realize that it does have a factor that's a perfect square, 4. And so we can separate it into the product. The square root of 4 then is equal to the whole number of 2. And that's what then gives us our final simplified answers of negative square root of 2, negative 2 root 2, and positive 2 root 2. All right, so this might have looked a little overwhelming when it popped up on the screen, but we're going to break it down. So at the top, we have our procedure, our steps for how to go about finding zeros from vertex form and using our algebra skills. So remember what I was saying in the prior knowledge, understanding that those zeros of -4 and 1 produced y values of 0. So we let y, which is often represented by f of x, become the number 0. And so it's shown here. That's the first step. And so f of x becomes 0 because zeros produce a y or function value of 0. Then we'll have an equation that will be a quadratic equation that we can begin using our undoing algebra on towards using our square root property. And so we would isolate the quantity squared. And then we can use our square root property. Again, that plus minus important. And then we have x plus 1. And then remember what we learned about here is that we need to separate these, the positive and the negative, and subtract the 1 from each of them separately, because in the plus minus, it doesn't work. This doesn't give us like a plus minus 1. We get a positive 1, but we get a -3, not a -1. So we can't use that math there to help us get both of our values correct, which will then be our zeros. So the biggest thing in these problems that we're going to be doing, we'll have a number of examples and a number of practice problems, is often what people struggle the most with is after using the square root property and taking the square root of both sides, simplifying everything and getting it into the final form that we would consider to be that structure that is appropriate to the problem. So The other thing is we're supposed to find the zeros without graphing, so using our algebra skills. And then notice we're supposed to also state whether the zeros are rational, irrational, or imaginary. And so we can't forget that part. And that's often what happens in problems like this, is that we get so focused on the first part, we can forget about the second part. So it's always a good idea to reread the instructions before you move on to another problem to make sure you did all the parts. Or highlight as I have done, and then look at that to make sure that you've accomplished all the parts that are highlighted. So we're going to begin finding the zeros of this function. So k of x is our y, so that becomes 0. And this creates our quadratic equation. And now we begin solving. So our undoing algebra says we undo the addition first. And then we would undo the multiplication, so dividing by -2. Watch your signs. Remember that these are all no calculator problems. Everything that we're doing here needs to be something that you can do yourself without the aid of a calculator. So a negative divided by a negative is a positive, so this is 32. This becomes our x squared. You can switch it around if you want to and write like x squared equals 32, but it's not absolutely required. If you do it here and take your square root, the plus minus goes in front of the square root of 32. If you do it here, it's in front of the square root of 32, either way. And so square and square root cancel, and that gives us x equals, and our positive and negative square root of 32. So here, one of the things we have talked about previously, number sense and knowing your perfect squares, knowing it as well as possible factors of small numbers like a 32. So knowing what the perfect square factor would be that's the largest is 16, and that simplifies the amount of work you have to do. So we have the square root of 16 times the square root of 2. 16 times 2 being 32, 16 being a perfect square factor. So it becomes the whole number 4. And now we can write our conclusion. So don't say x equals. Remember, these are zeros. So you apply it. So the zeros are, you can say equals, I'm fine with that, but you separate them. So you have a negative 4 root 2 and a positive 4 root 2. And then don't forget that second part. What was that second part? We have to identify whether they are rational, irrational, or imaginary. No i's showed up anywhere, so they're not imaginary. We do still have a root, so that means they are irrational. And that will finish up all parts of this problem. All right, let's look at another one. So the first few steps are always the same, okay, as far as, how you begin your basic undoing algebra, taking the square root of both sides. Don't forget that plus minus. After that is where the most differences are between the problems we're going to be doing in this lesson. So we begin by letting our d of x, which is y, equal 0. Now we begin using our undoing algebra to get x squared by itself. So we'd undo addition. Then we'd undo the multiplication. This time we have a negative divided by a positive, which will be a negative. 14 and 6 do have a common factor of 2, so I should reduce that. So I get negative 7 over 3 equals x squared. And again, you can switch it around if you want to, but you don't have to. Here's a biggie, and this is where I see a lot of mistakes happen with problems like this. So our next step is now to use our square root property. And in using our square root property, we're going to take the square root of x squared, and we're going to take the square root of this negative number, and the plus minus is in front of that. So I will see people who for some reason think that the negative on the 7/3 is the minus in the plus minus, and so they won't, this all of a sudden won't be a negative anymore, and that would be wrong, because the plus minus occurs when we take the square root. The 7/3 being negative, there's no square root yet, so you got to have both. You got to have the plus minus on the outside and the negative on the inside. So now the square and the square root would cancel, giving us x equals. All right, here's where we've got some work to do to get this into its simplest form. So first off, remember with the square root of a fraction is separate numerator from denominator. So we have the square root of -7 over the square root of 3. Then you have one of two options. You can simplify the square root of the negative first if you want to, or you can rationalize if you want to do that first before you do the other. Some people, it's sort of like you get to the point where you get so comfortable with it, you're kind of doing them at the same time. So for example, square root of -7, we have to realize, okay, well, that's square root of 7 times the square root of -1. That square root of -1, remember, is our imaginary unit I. So there's that part. The other part is the rationalizing part, where we multiply by a ratio of 1, such that we're turning that denominator into the square root of a perfect square. So we multiply by itself. So a square root of 3 times itself will become the square root of 9, which will become then 3, a rational number. But mathematically, it has to be a ratio of 1. So we have to multiply the top by the square root of 3 also. And so now what we've got is x equals. So we have the square root of 7 times the square root of 3. Now, a square root times a square root, remember, is still a square root. And then we multiply the 7 times the 3, so we get the square root of 21. And square root of 3 times square root of 3, square root times the square root is still a square root. 3 times 3 is 9. And then, of course, we have our I, which goes to the side. So now what I've got is I have to simplify my square root here. And this is another thing that I see, and I just caught it myself, that people lose the plus minus along the way. So we had that plus minus that has to come through all the way. So let's go back and grab that plus minus. And now simplifying the square root of 9 to our 3, we're going to get plus or minus the square root of 21 over the whole number of 3, and then times I on the side. And those represent our zeros in their simplest form. So the zeros are, or equal if you prefer, I'll do an equal sign on this one, the negative square root of 21 over 3 times I, and the positive square root of 21 over 3 times I. And then remember that second part, rational, irrational, or imaginary here. Because of the imaginary unit I, these are imaginary zeros. All right, that finishes up that one. Here is a practice problem. Please do this practice problem on your guided notes or a piece of paper. All right, let's take a look. So here, adding, you have your 0 equals, and then you should add 12 as a first step. Divide by 3, take the square root of both sides. Plus or minus should be in front of that square root of 4. 4 is a perfect square. That's a -2 and a +2. And so the zeros are -2 and 2. Those have no i's, so they're not imaginary. They have no root, so they are not irrational. They are both rational zeros. All right, back to an example that we're going to do together. Okay, beginning is exactly the same. So our f of x becomes 0. We have 0 equals this negative. You might want to write a -1 instead of just a negative, but you don't have to as long as you've got the negative there. All right, so now we start with our undoing algebra. So we have to start by undoing the addition that is outside the parentheses. So we must start by subtracting 4. 0 plus -4 is -4. Now we must undo the multiplication that is outside the parentheses. So we divide both sides by -1. Now that we have the exponent is the thing on the outside, this is where we use our square root property. So now we have plus or minus the square root of 4 and the square root of our quantity squared. Square and square root cancel. So this side's going to be x minus 3. Over here, we should recognize 4 being a perfect square. That square root of 4 is 2, and so we have a negative 2 and a positive 2. And we have to split them apart because in the next step, we're going to have to add 3 to each of them separately because they are rational numbers. We can't add to them together in a plus minus structure. So now negative 2 plus 3 is 1. 2 plus 3 is 5. Those are our x values, which means they are also the zeros. So the zeros of our function are 1 and 5, and those are both rational numbers. All right, moving on. Another example for us to do together. So the beginning is the same. G of x becomes 0. Now we start, remember, with undoing in reverse order of operations. So we start with addition, subtraction outside parentheses. Here we have addition, so we're going to subtract 24. 0 plus a negative 24 is negative 24. Then we undo multiplication, division outside parentheses. We have multiplication, so we undo that. This is going to give us negative 8. Now we are technically undoing the exponent. And to undo an exponent of 2, we use our square root property. So we have plus or minus the square root of negative 8 and the square root of our quantity squared. Cancels, leaving us with x plus 4 over here on the right side. And then we have to simplify our square root of negative 8. So remember, first off, that's the square root of 8 times the square root of negative 1. But 8 has a perfect square factor of 4. So that's the square root of 4 times the square root of 2. And then also times our square root of negative 1. So the square root of 4 becomes the whole number 2. Square root of 2 stays because 2 is not a perfect square. And our square root of negative 1 is our imaginary unit I. And then we have our plus minus. Now these, you could separate now if you want to, or you can wait. I'm going to wait because 4 is a rational number and 2 root 2i plus or minus, those are imaginary. There's no way we can combine those together into a new number. So when we subtract 4 to undo the addition that was in our parentheses, that negative 4, which is rational, is going to go at the front of the plus minus. So now what I have here, actually, let's do this. So this is our x, and then the rational part always goes first, followed by the imaginary part, like so. So now, in our conclusion, now we're going to split them. So our zeros are negative 4 minus 2 root 2i, and negative 4 plus 2 root 2i. And because of the imaginary unit I, they are imaginary. That finishes up this one. All right. Practice problem for you to try, either in your guided notes or on a piece of paper, wherever you have room. All right, let's take a look. So here in this one, you should have added 30 and then divided by 5, giving you this. And that is when you should have used your square root property. And there's the plus or minus in front of the square root of 6. And then when you subtracted the 7, giving you a negative 7, it should have gone in front of the plus minus because negative 7 is rational and the square root of 6 is irrational. So separating them, we have a negative 7 plus a square root of 6 and a negative 7 minus a square root of 6. It doesn't really matter which one you put first as long as you have them both and they are separated. Because of the square root of 6, that makes them both irrational. Another practice problem for you to try. Let's take a look. So here you should have started by subtracting 32 from both sides and then undoing the multiplication, dividing by -2. Negative divided by negative is a positive, so you have a positive 16 there. This is the step then where you should have then used your square root property, plus or minus in front of the square root of 16. And since 16 is a perfect square, we now have a -4 and a +4, and the +1 is added to each of them separately, giving you a -3 and a 5 as your zeros, and those are both rational numbers. All right, this is an example we are going to do together. So again, we start by taking our y function value and making it 0. Start now with our undoing algebra. So first we undo subtraction outside parentheses. 0 plus 5 is 5. Then we undo the multiplication outside the parentheses. 5/2. So here, remember, these are no calculator problems. So you are going to want to leave that as a fraction. Don't change it to a decimal of 2.5. All right, so now we're at the point we have our quantity squared isolated. So now we would be ready to take the square root of both sides, use our square root property. So we have plus or minus the square root of the 5/2, the square root of our quantity squared. So these cancel, and on the right side we have x minus 2. On the left side we have positive and negative, square root of 5/2. All right, so now you have a couple of options. You can simplify the square root of 5/2 right now if you want to, or you can add 2 to both sides and then simplify. Just because of space, I'm going to go ahead and add 2 to both sides, and that 2 being rational is going to go in front of that plus minus. And so my x's now are 2 plus or minus the square root of 5/2. But this guy, we've got to simplify. And so you got to recognize that you need to simplify. That's another thing that I notice of students who haven't practiced their math enough, is they don't even remember that that's something that they need to simplify and change the structure of. But square roots of fractions are not in simplest form. You can't, because they represent a square root in a denominator because of the 2 in the denominator. And so we simplify them to get that rationalized. So remember, this would be the square root of 5 divided by the square root of 2. We would now multiply by a ratio of 1, and that ratio of 1 would be our denominator, square root of 2 over square root of 2, and then multiplying straight across, square root of 5 times the square root of 2 would become the square root of 10. Remember, square root times the square root is a square root. Square root of 2 times the square root of 2 is a square root of 4. And then we can simplify the square root of 4 to the whole number 2. So we still have that square root of 10. Now it's over the whole number of 2. And we still have this 2 plus or minus part. So those are our zeros now in their simplest form. So now we're going to make our conclusion. So the zeros are 2 minus the square root of 10 over 2, comma 2 plus the square root of 10 over 2. And there's no I, so they're not imaginary, but they do have a root still in them, that square root of 10. So that makes them both irrational. That finishes that one off. All right, another example for us to do together. So again, the biggest issue here is to make sure that you have examples that hopefully give you something to refer to for all the different issues with our algebra in the simplifying portion, which is where a lot of people tend to struggle the most. So we start, and now we would undo the subtraction that's outside the parentheses. So we have 27 now equals -4 times our quantity squared. We would now undo the multiplication, dividing by -4. Now some people mistakenly leave that negative with the 4, but a negative fraction, the negative belongs at the top or to the side. So with these problems, it will be best to move that negative to the 27. And now we're in a position now where we have our quantity squared isolated. So now we're undoing our exponent. And to undo an exponent of 2, that's our square root property. So remember, plus or minus. Then we have the square root of the negative number, square root of the quantity squared. Those cancel. So this is going to give us an x plus 8. And I'm just going to leave this as it is right now. And you can simplify that square root of that negative fraction right now if you want to, or you can wait. I'm going to wait again just because of space. So I'm going to subtract 8, which is rational, so it's going to go in front again, giving me negative 8 plus or minus the square root of this negative fraction. All right, so now let's talk about the simplifying here. So this, remember, is the square root of the numerator of negative 27 over the square root of the denominator of 4. This time, this doesn't always happen, but in this problem, the square root of 4 is already a perfect square, so we can just change that to the whole number of 2. Don't overcomplicate a problem. Now you might think you're done, but nope, because that square root of negative 27 can't remain as it is. So one of the things we have to realize, okay, well, that's square root of 27 times the square root of negative 1. That square root of negative 1, that's our imaginary unit of I. So we've got that part. But the other thing is that we have to realize 27 has a perfect square factor of 9. It is the square root of 9 times the square root of 3. So this will become the whole number of 3, and then the square root of 3 will stay. So what we should realize, we still have this negative 8 plus or minus. This became 3. Still have the square root of 3 over this denominator of 2 times I to the side. This is your A plus or minus BI form. That's what we're going for there. That complex number form, A plus BI or A minus BI. So now we can make our conclusion about our zeros. So we've got negative 8 minus 3 root 3 over 2 times I, and negative 8 plus 3 root 3 over 2 times I. Because of those imaginary units of I, they are both imaginary. Like so. That finishes up this one. All right, here's a practice problem for you to try, again, on your notes or on binder paper. Let's take a look. So here, after setting p of x equal to 0, you should have started by undoing the addition, subtracting 7, and then dividing by 3. That's going to give you the square root of a negative 7/3. And here, the simplifying of that is done first, and then the 5 is added, which is another way to do it. That's the other way that I was talking about. Let's take a look at the simplifying. So this separates. We have the square root of 3 in the denominator. The square root of negative 7 got broken apart. And then rationalizing this time, there's your ratio of 1. That's going to give you that square root of 9, which becomes 3. 7 times 3 gives you a square root of 21, and then your I. And then adding 5, which is rational, it should have gone in the front. Another practice problem for you to try. All right, so here, after making q of x 0, you should have ended in the subtraction, adding 5, and then dividing by 6. So you are taking the square root of the fraction 5/6. So here's where we see that simplification. So separating it, square root of 5 over square root of 6. Rationalizing the denominator, there's your multiplying by the ratio of 1. Square root of 6 times square root of 6 is square root of 36, which becomes 6. Square root of 5 times square root of 6 is a square root of 30, which stays as it is. And then subtracting 9 from both sides, that minus 9 goes in the front, and that then gives you your two zeros separated, and they are both irrational because of the square root of 30 being a part of them. Another practice problem to try. Let's take a look. All right, so for this one, after your 0 equals, you should start by adding 50 and then dividing by negative 1. So what you're taking the square root of is negative 50. And so here it is shown as a simplifying. That's your square root of 50, but 50 has a perfect square factor of 25. And here's your square root of negative 1. That becomes your I. Square root of 25 is the whole number 5, and the square root of 2 is still there. Subtracting the 2 from both sides, that minus 2 should be in front of your plus minus. And then here the zeros are shown separated because of the I. We say they are imaginary. All right, closure. Here it says Gary found the zeros of this quadratic function. His work is shown. Explain the error that Gary made, and also what are the correct zeros of the function. Take a few minutes. All right, let's take a look, see how you did. So hopefully you said something along the lines explaining that Gary made the error of letting the x be 0 instead of f of x. So the correct math was to let f of x be 0, and he had x be 0, and that's not right. And then your math here hopefully gave you the zeros of negative 6 and negative 2, which are both rational numbers. All right, that ends this lesson. I hope you have a wonderful day.